All right, this video we're going to look at the mean or expected value, variance, and standard deviation of a binomial distribution. So recall that expected value, e of x, of a probability distribution is the mean, mu, of that distribution, of that distribution. I'm keeping that there. In other words, it's the value that we're going to get closer and closer to if we perform the experiment indefinitely. So as we increase the number of times we perform an experiment in the millions, billions, trillions, it's going to be the value that we get closer and closer to as an average of the overall distribution. So in a binomial probability distribution, the mean, mu, can be found by multiplying the number of trials by the probability of success. In other words, just take n times p and you'll have your mean or your expected value for a binomial distribution. It's fairly easy, and in fact, it looks a lot friendlier than the mean of a general distribution like we looked at in the last section. So for binomial distributions, the variance can be found by just multiplying the mean by the probability of failure. So here's our mean, n times p. The probability of failure is 1 minus p. So your variance is n times p times 1 minus p. It's a very easy calculation for the variance of a binomial distribution. And as always, standard deviation, just take the square root of both sides. And you get standard deviation as n as the square root of the variance equals the square root of np times 1 minus p. So the number of trials, the probability of success, and the probability of failure. Example 3, a multiple choice test consists of 10 questions with 5 answer choices per question. What is the expected number of correct answers a student will get by guessing alone? So if the student did not study for their test and they have a 10-question test or a quiz or whatever, and each one has 5 choices, let's say A, B, C, D, E, how many can we expect the student to get by purely guessing, which hopefully this is not you. So our mean, our expected value, is the number of questions times the probability of guessing correctly. So if each one has 5 choices, your probability of guessing correctly is 1/5. So 10 times 1/5 is 2. So we would expect this student to get 2 questions correct by guessing alone on a 10-question multiple choice test that has 5 answer choices per question. So can expect to get 2 questions correct out of 10, but it's not guaranteed because there is variance involved and standard deviation involved. So what is the standard deviation of the number of correct questions via guessing? That is not easy for me to say. So, all right, well, standard deviation is the square root of variance, which is really easy to calculate if you've already calculated your mean. So we had 10 times 1/5 is the mean, and then if we have a 1 out of 5 chance of getting the question right, that means we have a 4 out of 5 chance of not getting it right, which, hopefully you're doing well or the student here is doing well in other stuff in the class. So calculating this out, we get about 1.265. So our standard deviation is about 1.265 questions. So we'd expect to get 2 questions right, although it's not a guarantee. And then on average, we're about 1.25 questions away from that average for that particular experiment. So interpreting the standard deviation in this case, if we perform the same experiment several times, so let's say we give millions and millions and millions of students a 10-question multiple choice test where each question has 5 answer choices and they're going to guess on their answers because they have no ideas. So in that case, we'd probably give them a test on something they would not be expected to know at all. So we can hopefully guarantee that they're just guessing. Around 95% of the time, the number of correct guesses are going to be within 2 standard deviations of our mean or expected value. So again, we said that our mean is 2 in this case, and our expected value is about 1.25 questions each of those. So around 95% of the time, a student is going to guess between 0 and 4.5 questions correctly. So we take our mean of 2 and our standard deviation is about 1.25. 2 standard deviations is 2.5. So 2 minus 2.5 is, well, negative, so we'll just say 0. 2 plus 2.5 is 4.5. So 95% of the time, the student's going to get between 0 and between 4 or 5 questions correctly by pure guessing alone. Again, it's not a guarantee that they're going to get even 2 of them right by guessing, but in the long run, that's what we would expect to happen. And in the long run, around 95% of the time, our student's going to get between 0 and 4.5 questions correct. So, all right, that about does it for this video. Thanks for watching. I'll see you next time.